Section 6.1 Graphs of sine and cosine functions. In this section, you will graph variations of y equals cosine x and y equals sine x. Also use phase shifts of sine and cosine functions. Let's recall the unit circle. On the unit circle, so let's say we have this angle here. Cosine tells us the x and sine the y coordinate. So this point here, we have here x, y. So this is the cosine, this is sine. What would these functions look like if we plotted them on a coordinate plane? So example number 1. Let's graph y equals sine x, and let's start by making a table of values. When x is 0, sine of x is 0. So we have that here. This is when it is 0. So we know that this is 1, 0, and this is the sine. It is equal to 0. Then next is pi over 6. So let's say this is pi over 6. And this is square root of 3 over 2 and 1/2. So that's why pi over 6 is 1/2. And the next pi over 4. This is pi over 4. And we know that this is square root of 2 over 2 and square root of 2 over 2. And this is sine. The y coordinate is square root of 2 over 2. Then pi over 3. So this is pi over 3. And we know that this is 1/2 and square root of 3 over 2. The y coordinate is square root of 3 over 2. Then pi over 2. So this is pi over 2. And we know that this is 0, 1. And the y coordinate is 1. This is quadrant 1. And in quadrant 2, the y is also positive. So 2 pi over 3 is the same as pi over 3, square root of 3 over 2. Then 3 pi over 4 is the same as pi over 4, so square root of 2 over 2. And 5 pi over 6, yes, that is also 1/2. That's why our pi, this is a pi here, negative 1, 0. So that's why the y coordinate of pi is also 0. Okay, so let's plot all these points. And that's going to be our y equals sine x. The first one, 0, 0. Next, pi over 6 is 1/2, 0.5. Pi over 4 is square root of 2 over 2, somewhere here. Then pi over 3 is square root of 3 over 2. Then pi over 2 is 1. 2 pi over 3 is square root of 3 over 2. 3 pi over 4 is square root of 2 over 2. 5 pi over 6 is 1/2, and pi is 0. Then we can grab a 7 pi over 6, that is, yes, negative 1/2. 4 pi over 3. Then 3 pi over 2 is negative 1. 5 pi over 3. 11 pi over 6 is negative 1/2, and 2 pi is 0. Okay, and this is the graph of sine x. Okay. Next one is example 2. This time, let's graph y equals cosine x. So let's start by making a table of values, then plotting it on the Cartesian plane. So if you go back here, we note that cosine tells us the x-coordinate. So for 0, the x-coordinate is 1. For pi over 6 is square root of 3 over 2. Pi over 4 is square root of 2 over 2. Pi over 3 is 1/2. And pi over 2 is 0. So let's use those here. Pi over 6, again, square root of 3 over 2. This is square root of 2 over 2. This is 1/2. Pi over 2 is 0. In quadrant 1, cosine is positive and negative in quadrant 2. So that's why this is negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, and that's why at pi is negative 1. Okay, now let's plot all this, and that's going to be the graph to see the graph of y equals cosine x. Zero is 1. Pi over 6 is square root of 3 over 2. Then pi over 3, we have here 1/2. This is pi over 4. Pi over 2 is 0. 2 pi over 3 is negative 1/2. 3 pi over 4 is negative square root of 2 over 2. And 5 pi over 6 is negative square root of 3 over 2. Pi is negative 1. Then 7 pi over 6. Then 4 pi over 3 is also negative 1/2. And 3 pi over 2 is 0. 5 pi over 3 is 1/2. 11 pi over 6. And 2 pi is positive 1. So now, this is the graph of cosine x. Okay. So some key characteristics of the graphs of sine and cosine. So again, this is the graph of sine, and this is the graph of cosine. Earlier when we plot all those points, we got this for sine, this part here from 0 to 2 pi, and for cosine, this part here from 0 to 2 pi. The sine and cosine function have several distinct characteristics. They are periodic functions with a period of 2 pi. Look at this highlighted parts here, from 0 to 2 pi. Periodic means repeats itself. That's why, look at this. This is from 0 to 2 pi. This is the graph. Here also from 0 to negative 2 pi is exactly the same thing. Same thing here. That's a graph of one period of cosine, and this is sine. So the domain of each function is, what do you think? Yes, from negative infinity to positive infinity, and the range is, since it's a unit circle, yes, that's from negative 1 to positive 1. We can also say that the graph of sine x is an odd function. So it is symmetric about the origin. And then the graph of cosine x is, this cosine x here is even, so it is symmetric about the y-axis. Next, variations of sine and cosine, and let's investigate sinusoidal functions. As you can see from the graphs before, sine and cosine produce wave-like graphs. Do you agree? But just as we know that not all waves in the ocean are the same, some are taller or some are longer, not all sine or cosine functions are identical. So a function that has the same general shape as sine or cosine functions is called a sinusoidal. And their general form is, y equals 8 sine bx minus c plus d, and for cosine, a times cosine bx minus c plus d. So again, this is the general form. Just like if you remember, let's say for a line, we have mx plus b. For quadratic, a times x minus h squared plus k. For exponential, say ab to the x. So this is for sine and cosine. So again, by showing the graph of sine, so this is your A, and we call it as an amplitude. That is the height from the midline of the graph to the crest or the trough. So this is an amplitude, this is also an amplitude, and this is the midline. Okay, so this is from 0 to 2 pi. So amplitude we use as the absolute value of A. The next one is the period. That is how long it takes for the graph to start repeating itself. B is not a period. So the period formula is actually 2 pi over B. So if you want to get B, that is 2 pi over the period. Okay. The phase shift is the horizontal shift of the basic sine or cosine graph, and that is from the general form, that is C. So the C here, that is the phase shift. And then the vertical shift, moves the graph up or down from the midline, and that is your, yes, that is your D. And the midline is actually equal to D. So y equals D is also the midline. Okay. So please make sure to remember all this: amplitude, the period, the phase shift, and the vertical shift. And those are the A, B, C, and D. So example number 3 here, let's determine the midline. the amplitude, the period, and the phase shift of the function y equals 3 sine 2x plus 1. So here, let's identify A, B, C, and D. So A is, yes, 3. The next is B is equal to 2. C is 0. And this D is equal to 1. So again, this is the amplitude. B is 2. Midline, we can say that midline is, yes, your D, which is y is equal to 1. And period is, remember, this is 2 pi over b, and your b is 2. 2 pi over 2 is pi. So take a look at this graph of y equals 3 sine 2x plus 1. You have this amplitude here. The midline is at 1. So this is the midline at 1. And you have the amplitude of 3. So you go up 1, 1, 2, 3. So that's why this is from 1 to 4 is 3. Same thing here. From the midline, you go down. This is also your amplitude, which is also 3. 1, 2, 3. So that's why that's an absolute value of the, A. And aside from that, a period, it says this is pi. By looking at this graph here, look at this graph from here to here, from here to here, that is one period from 0 to pi. So that makes it 2 from 0 to 2 pi. So that's why you have another one here. Okay. All right. So that's the graph of y equals 3 sine 2x plus 1. This time, determine the formula for the cosine function below. So we know in general form, we have y is equal to a cosine of bx minus c plus d. Here, by looking at this graph from 0 to 2 pi, we have this graph here. Earlier, when we graph, since we're talking about cosine, when we graph cosine from 0 to 2 pi, it looked like this. From 1 to, right? So here it started from the bottom, so that's why A must be negative. So since we know that A is the amplitude, and this is cosine, so meaning we have here as the midline at 0.5. So what's going to be the amplitude? That is from the midline to here or here. So these are the amplitudes. And what is this? From 0.5 to 1. Yes, that is 0.5. So A is 0.5 and it must be negative. Then period is look at this graph of cosine that is from 0 to 2 pi. So period is 2 pi. And now we will be able to solve for b. So remember, it is 2 pi over the period. So 2 pi over 2 pi is equal to 1. And then c is the phase shift. And we can see that there is no phase shift. So that means c is equal to 0. Then d, and we know that the midline here, this is the midline, that is at y is equal to 0.5. So d is equal to 0.5. So with this, we'll be able to write our formula. So that is y is equal to a is negative 0.5 cosine of b is 1, so that's 1x, and there is no phase shift, c is 0, so this is just simply cosine of x, and your d vertical shift is 0.5, so plus 0.5. So this is the answer. Okay. Alright, let's try example number 5. Determine the amplitude, period, phase shift, and vertical shift of the function, and then sketch its graph. So this is the given. Y equals negative 2 cosine pi over 2 of x plus pi plus 3. The amplitude is the absolute value of negative 2, which is 2. The period is equal to, remember, it's 2 pi over b, and b is pi over 2, so it's 2 pi over 2. That is 2 pi times the reciprocal of this, 2 over pi is equal to 4. And the phase shift, or PS, is pi units to the left, this plus, and then the vertical shift is plus 3, so meaning up 3. So, and with this, you can say that our midline is y equals 3. Okay, so how do we graph this? I'm going to start with the midline. Midline is at y equals 3. So this is the midline. And the amplitude is 2. That's why if you go up 2, 1, 2, so that's why we have 5 here. And you go down 2, 1, 2 at 1. And then we know that the graph of cosine of x is like this. But if it's negative, it's gonna be look like this. And since the period is 4 and b is pi over 2, so you expect 4 like this, like 1, 2, 3, 4. That is, since your phase shift is pi units to the left, so from negative pi to pi you should have 4 of this. And pi over b is pi over 2, it's pi over 2, negative, this is pi over 2. So you should have like this, from negative pi to negative pi over 2, another one from negative pi over 2 to 0, oops, Doesn't look good. And from 0 to pi over 2, and from pi over 2 to pi. And you know that this is continuous, so you expect that you can have like that to the left and to the right. So that is the graph of negative 2 cosine pi over 2x plus pi plus 3. Okay, also I suggest that you try this, you type this, go to Desmos, and you will see the exact graph of it. Okay. Next problem. The London Eye is a Ferris wheel with a diameter of 135 meters. It completes one rotation every 30 minutes. Riders board from a platform 2 meters above the ground. At the bottom of the wheel, express a rider's height above the ground as a function of time in minutes. So here A is the radius. Of the circle. So remember, y is equal to a cosine of the general form bx minus c plus d. So since a is the radius and the diameter is 135, so half of that is yes, so that is 67.5. And it says here that it's 2 meters above the ground. So this is 2 meters here. So meaning we can say that our d, the vertical shift, is 67.5 plus 2, which is equal to 69.5. And period is, we know that it's 2 pi over b. So we can solve for our b, which is 2 pi over the period. And it says here its rotation is every 30 minutes. So b is equal to 2 pi over 30, which is equal to pi over 15. So to write our equation here, so that's going to be y is equal to our amplitude. Oh, by the way, express a rider's height above the ground as a function of time. So that's going to be negative 67.5 times cosine of our b is pi over 15 x plus 69.5. Okay. Next, let's answer some lecture questions here. So why are sine and cosine called periodic functions, and what are their period? So if you notice, they actually repeat after 2 pi. So that's why we call it them. Sine and cosine are periodic functions. Then example number 2, for the following exercise, graph full methods of the function and say that the amplitude, period, midline, and phase shift, if any. Also, please label the maximum, the minimum y values and their corresponding x values. So what do we have here? This is the given f of x. we know that the phase shift here is x plus pi over 3, so that is negative pi over 3, meaning it's negative pi over 3 to the left. Amplitude is, you see a negative here, so that's negative 1. Midline is, your vertical shift is plus 1, so that is y is equal to 1, and the period is 2 pi. So to graph, midline is at 1, and period is 2 pi. Say this is pi, this is 2 pi, and amplitude is 1, so meaning you go up 1 here, and this is 0. This is cosine negative, and since your phase shift is pi over 3, that's pi over 3 to the left, so this is negative pi over 3 here, and you should start here, and you should have one cycle and another one like this. Okay. Then next problem, the Ferris wheel is 25 meters in diameter, and passengers board from the platform that is 1 meter above the ground at the bottom of the wheel. The wheel completes 1 full revolution in 10 minutes. Find a formula for h of t for a person's height in meters above the ground in t minutes after the wheel begins the turn. So here, since the diameter is 25, just like our example earlier, so meaning the radius is equal to 12.5, and the amplitude is 12.5. And it starts at the bottom, so that's why your A is going to be negative 12.5, and our midline is, it's 1 meter above the ground, so it's 12.5 plus 1 is equal to 13.5. Then period is 1 full revolution is 10 minutes, so that is equal to 10. So we can solve for our b, which is 2 pi over a period, so 2 pi over 10 is equal to pi over 5. And there is no phase shift. So now we can write a formula for ht, that is, A is negative 12.5 cosine of, so yes, pi over 5 in terms of t minutes, so we're going to use t plus your d is 13.5. So this is the answer. Okay, and that's it for section 6.1. Let me know if you have any questions. Okay, thank you.